Welcome. This is Chapter 5, and this is John Waddick, your host, and we're going to learn about how to do matrices and to solve simultaneous equations, do all kinds of neat stuff. You know, about a year from now, you're going to be moving into courses like statics and circuit analysis, and you're going to have multiple equations and multiple unknowns, and Excel can really be your friend there. So hold on to this workbook because you will need it later. All right, let's get into this one. We're in the addition worksheet. This is from pages 222 to 226 of the textbook. And the first stuff is just typing things in. Okay, so we're going to type all that stuff in. Now, one of the things I'm going to be looking for is to see that you have these formatted nicely. So I'm going to show you how to format stuff nicely. So when you first type this stuff in, it's going to look like that. But we want it to look like matrix form. We want to make it look nice, like this one down here. So first thing off, we're going to highlight that. We're going to come up here and we're going to center content. Okay, so we center all the numbers, make them look nice. Next, we want to have a border around the left and right. So let me show you the easiest way to do that. You come up here to the Borders tab. It's coming off of the Home. I come down here. Don't choose any of these things. Go right down to More Borders. This gives you a customized choices. So what you want is you just click on the left and you click on the right and you get a left and a right border. So you put OK and there we go. So make all your matrices look like this, centered with left and right borders. All right, so one of the things I've done is I've named this A. Now I'm probably going to be using the variables A and B many times again in this sheet. So I'm just going to remind you that when you define the names of these, you're going to hit Formula, use the Name Manager. Okay, when we see A here, you can see I've used A many times. I've got it all with different scopes of just single sheets so that there's no confusion between the sheets. If you name a cell with a scope of just a sheet and then you copy that sheet over, the new copy will have also variables that have just the scope of the copied sheet. So even if you copy the original sheet and the copied sheet will have distinct variables with scopes of only their respective sheets. I hope that made sense to you. So anyway, use variables with a scope of only one sheet throughout this workbook. All right, so I've got A defined, as you can see right here, and I've got B defined. So first thing it says is, let's do an element by element. So let me get off of here and get rid of this and show you just how we're going to fill this. So if you're going to add element by element, you want to do this. So in the first cell, we want to add the top left element of A to the plus the top left element of B, and we'll put OK. And we get a 5. Now you say to yourself, geez, I got to do that always? No, because these are relative addresses. Okay, so if we drag this down, it's going to take the 7 and the 6. So watch what happens. We'll just drag this down. It uses relative addresses, and look at that, 7 and 6, and then the last one down here, whoops, it uses those. We can also drag them to the right and take all three at once, and there you go. All right, so that's what element to element. But when I dragged over, it messed up my border. So I'm going to come up here, go to Home, go to More Borders. Let's see, let's go to None. Gets rid of all of them, and then we'll put these back on. Okay, so if you have real messed up borders, just go to None first, and then you can choose. All right, now this next one, you can use array math. Now array math is something special. You can't just enter the formula and hit enter. Notice that I have a nice little heading here that tells you that once you put in your operation, you're going to have to do Control Shift Enter. Now, not only that, but before you do the operation, you're going to have to tell, by highlighting, you have to tell Excel how big the result is going to be. So if we add matrix A and matrix B, we're going to get a sum matrix that's also going to be the same size as A and B. So to add two matrices, you have to have two matrices that are the same size. So first thing I'm going to do is going to highlight this area, because I know if I have a 3-row and 2-column set of arrays, my result is going to be a 3 by 2. So I've highlighted that. That's the first thing you have to do. You have to tell Excel the size of the result here. All right, next thing, we're going to put a formula in. I'm going to put equal. Now, unfortunately, I can't just highlight this and it'll come up as a cell A. Okay, so I just have to actually type in A here. Okay, so I do that. Okay, so there's A. And then I'm going to just put plus B. And notice that the two matrices are highlighted here. So it's better to use variable names here so that it's really easy to track what you're doing. All right, now at this point, you can't just put OK or enter. You have to do these three things. So you're going to need two hands. You're going to hit Control, you're going to hit Shift, and then you're going to hit Enter. Okay. When you do that, the entire matrix fills with that operation. And every cell in there says curly brace equal A plus B curly brace. I'm sorry. You do not type in those curly braces. Those curly braces come from the Control Shift Enter. Okay? So there we go. There's the first one, addition. Let's go to scalar multiplication. Scalar multiplication is when you just take a single number and you multiply by every element. You multiply every element of the matrix by that scalar. So if we have this A, 1, 3, 7, 2, 8, 1, and we multiply each element by 10, you can see this is the result. Now, to do it manually, because I've named the scalar cell up here 10, S, that is an absolute address. So I can get rid of this, and all you have to do is put equal. You can click on the S, and then you're going to do times this first element. Okay. Now I can just drag this to the left, and then I guess it doesn't let me go down. All right, now I'm going to go down. So it fills the matrix up. Once again, the borders seem to be messed up on me. I go to more borders. First thing you do is put none. That gets rid of those. Put them on the outside. Put OK. Everybody's happy. All right, let's take a look at the cell. Notice that no matter what cell I go to, the 10 is always used. Go to the next one, the B7. Okay, so the absolute address never changes as we drag, but these relative addresses drag or update as we see. Okay, now you can do this operation in one step, because if you multiply a scalar by a matrix, the resulting size is going to be the size of that matrix. So you highlight 3 rows by 2 columns, and we've got to start with an equal sign. So equals, and I have already defined S, so S times A. Okay, and remember the special secret passageway. It's Control, Shift, Enter, and we are done. Remember, the curly braces are something Excel puts in after you do the Control, Shift, Enter. It's not something you type in. Let's look at matrix multiplication. All right, so matrix multiplication. You cannot just multiply any two matrices together. There's a special rule. Okay, so let's first define these two matrices. So when we say a matrix is 3 by 2, it means that it has 3 rows, 1 row, 2 rows, 3 rows, and 2 columns, 1, 2. So we're always going to list the size rows times columns. The second one only has 2 rows and only 1 column. Now these two may be multiplied together because the rule is the number of columns of the first has to be equal to the number of the rows of the second. So if you wrote these out horizontally, you said A, which is a 3 times 2, and you're going to multiply that by B that had 2 rows by 1, what you really say is that these two inner numbers, the 2 and the 2, okay, those have to be the same in order to be able to multiply these together. Okay. Now, if I just copy this over and put it there, I could not multiply B times A because the number of columns of the first, which is 1 here, does not equal the number of rows in the second, 3. So just remember, to multiply two things together, the inner numbers on the sizes have to be equal, the 2 and the 2 here. So since we can do A times B, the next question is, how big is the resulting matrix? Okay, so with the resulting matrix, what you do is use the outer dimensions, the 3 from A and the 1 from E, for the size. So that means that the resulting matrix is going to be 3 rows and 1 column. And that's written up here. The dimensions in a product, the number of rows of the product equals the number of rows of A, which is the first thing. And then the number of columns in the product is equal to the number of columns in E, which is the second thing. So our resulting thing is going to be 3 rows, 1 column. That means when I do this operation, I'm going to have to highlight 3 rows and 1 column. Now you can't just say equals A times E. Okay, in fact, if you want to try that, go ahead, but I can guarantee it's not going to work. So let's just put equals A times E, and I'll do Control Shift Enter, and that is not the right answer. Okay, so that's not how you do it. You do it this way. Equals, there's actually a special function for doing this, MMULT. Okay, matrix mult. Parentheses. I'm going to use A and E. Close parentheses. Now, do you just hit enter? No. We do Control, Shift, Enter, bam, there we go. Their answers look pretty good. And this matrix mult, if you're following along, that was on page 228 to 231 of the text. Very similar to that, just to give you some more practice, is matrix multiplication number 2. We're multiplying A times G. Is that allowed? Well, since the second dimension, 2 here, which is the number of columns of A, is equal to the number of rows of G, the inners match up, so we can do this operation. All right. Now, how big is the resultant multiplication or product going to be? Well, you take the rows of the first times the columns of the second. So it's all that. All right, you should be able to do that from here. Let's look at transpose. All right, let me just clear this out here. We're going to do transpose in couple different ways. So here we have a matrix A, which has been defined in the scope of just this transpose worksheet. And one thing you can do is you can do a copy, Control C, all right, and then you can move over here and you can do paste, but you want to do paste special. So I just do paste special over here, and there's an operation here called transpose. You just do that, you put OK, it transposes it over here. Now it messes up the borders. So what do? You go to borders, go to more borders, do none, gets rid of them all, just put them on the left and right. There you go, nice looking thing. All right, there's also a transpose function. So probably most people would use that. So you have to first highlight anytime you do a matrix operation. You have to tell how big the resultant is. What a transpose does is it takes the first column and makes it into the first row. Second column becomes the second row. So a 3 by 2 matrix is going to end up being 2 by 3, meaning 2 rows, 3 columns. So you first have to tell Excel how big the result of your operation is going to be. Then we're going to type in, and there's a function called transpose, and then I'm just going to put a comma. No, just there's only one argument, so it's just a. And then we do Control Shift, Enter, and there's the transpose. Pretty nice. We're just flying through. Alrighty, a very important operation with matrices, especially in solving simultaneous equations, is computing the inverse of a matrix. All right. Now, the inverse of a number for multiplication, I'm just going to come over here. So if someone said, what's the multiplicative inverse of 5? Well, you would say, well, it's 1 divided by 5, right? So equals 1 divided by 5, which is 0.2. Now, the reason why 1 over 5, which we can put this in as in fact, let's just put it in as 1 divided by 5. We can do that. Now it thinks it's January 5th. By the way, that's my birthday. Now the semester is going to be over, so you're not going to be able to get me a birthday present. But hey, maybe you'll have me in class. But keep that in mind. Oh, we're not even in session on January 5th, so I guess you're off the hook. Alrighty, so anyway, let's go. We don't want that. We want that as a fraction. Holy smokes, how does that come up as a fraction? 1 divided by 5? Okay, so I'm going to go into more numbers here. We go up to 1 here. We put OK. Oh, because it thought that was a date, and it did a conversion into a crazy number. Okay, now 1 divided by 5, it's in as a fraction. All right, with all that said and done, equals 5 times its multiplicative inverse. What should the answer be? Enter. 1. Okay, let's keep that in mind. Well, that means when we get the inverse of a matrix, there should be something with 1s involved. Okay? By the way, if you take this result of the number and its multiplicative inverse, if you take this 1 and multiply by your original number, you get your original number back. Okay? Well, keep that in mind. All right, so I've got a matrix. I've named it J. We have another one called K. Now, before you go off and do an inverse, you first have to determine if this is if this matrix is said to be singular. It's singular if its determinant function, which you see up here, determinant, mdeterm, if that is equal to 0, then you can't take the inverse of the matrix. It's said to be singular. Okay, so mdeterm, and then you do the array. And that's not, you only have to highlight one cell for that. Okay, so let's get the inverse. We can't do K, but, and these are some things I'm adding down here. We can't do the inverse of K because it's singular, but we can do this one. All right, so first thing we have to do is if we take the inverse of a matrix, first of all, it can't be a singular, and 2, it has to be square, okay? So you have to, the result of a 3 by 3 inverse is going to be 3 by 3. So it's going to be equals, now what's the name of the function here? Well, I think it's matrix inverse. M inverse? No. Let's try just IN, inverse. Okay. No, so what you do is you look in the book, or we can go into the functions and find it. But anyway, we are on page 234 of the book, so the operation is matrix inverse. Okay, well, let's try again. So it's equal M inverse. Oh, there it is. Just typed it wrong, I guess. Double click. All right, matrix inverse, and I only need one argument. It's going to be J. Okay, remember, Control Shift, Enter. There's our matrix inverse. Now, if someone said to you, are you sure that's the inverse? You're going to look at these numbers and say, I don't know. Well, here's the thing. Just like over here with the multiplicative inverse, if you take a matrix and you multiply by its inverse, let's see what we get. Okay, so we're going to do equal matrix mult of J comma J inverse. Okay, so those two, Control Shift Enter. Oh, it comes out to be this. Now when you do it, you might have it come out looking like this because it's going to be in a general format. And you say, gee, what's that? Well, let's just override this and we're going to go to a number format, and you can control how many decimal places you put. But this is what you get when you multiply a matrix by its inverse. It's called the identity matrix. It has ones just along this major diagonal. Well, if that's indeed the identity matrix, then which is the result of this multiplication, let's see what happens if we multiply J by the identity matrix. So let's put that over here. Now you're saying, is that allowed? Well, yeah, we got a 3 by 3 multiplied by a 3 by 3. So the number of columns 3 here equals the number of rows in the second one, so we're all good to go. And the result is a 3 by 3. So you can always multiply two square matrices of the same size together. Okay, so I'm going to put equal matrix mult of J comma I parentheses. Control Shift Enter. Hey, you get your matrix back again. So hopefully you've learned something. When you take the inverse of a matrix, you can check to see if it's correct by multiplying the original matrix by the inverse. You should get the identity matrix. Anytime you multiply a matrix by the identity matrix, you get this. Now, if this was only a 2 by 2 matrix, then your identity matrix would have been 2 by 2. Okay. So that's a little bit about inverse. Well, what's it good for? Well, it's good for a lot, like solving an equation. So you're looking at solving equations, which is page 237 to 239 in the book. All right, so if you have some equations, so you're going to have to take a look at 237 in like figure 5.3. It has the three equations and three unknowns, x1, x2, x3. So the first thing is you create what's known as a coefficient matrix. These are the coefficients out in front of the x1, x2, and x3. Now, if there was an occasion where one of the equations maybe didn't have an x3 in it, you would have to still put a 0 in that location, or you would have to put a 0. All right, so these are the numbers that are multiplied by your multiplied against your three unknowns on the left side of the equation. Now, on the right side of the equation is this right here, which we're just calling RHS. What does that stand for? Rush Henrietta School? No, it doesn't. Sorry. It stands for right-hand side coefficients. We're going to take the determinant of these coefficients. We see it's not 0. So this means that we can get the inverse. So now you get the inverse. All right. Now if you multiply the inverse by the coefficient, okay, so you take this inverse times the left side of your equations, you get the identity matrix. Okay. And then remember, if you take the identity matrix and multiply your original coefficient matrix, you get your coefficient matrix back again. That's what we did on the previous sheet. Now, how do you get the answers to your sheet here, or what do you know the values of x1, x2, and x3? It's very easy. We're going to multiply the coefficient inverse by the right-hand side. Is this allowed? Well, the coefficient has 3 rows, 3 columns. Remember the second dimension, 3 columns. So the first one has 3 columns. That means the second one in the multiplication has to have 3 rows, and this does. Now, how big is the resultant thing going to be? Well, it's going to have 3 rows because that's what the first one has, and it's only going to have 1 column because that's what the second one has. I know I'm talking kind of fast. Believe me, I did not have any caffeine. I don't drink any caffeinated beverages at all. So matrix mult of COEFF, coefficient, underline, inverse. Okay, so that one, comma, RHS, that one. Now we do Control Shift Enter, Control Shift Enter, and hey folks, that's our answer. Okay, how's that for doing things? All right, let's move on. Let's look at some applications for engineering. Multi-loop, which is page 239 to 241. All right, on 239, they have a circuit. So they do something called, I guess, mesh analysis or some loop analysis, and they come up with some equations, and they get a coefficient matrix about which they're going to call C. Okay, because we have some equations. I wish they had a number for it, but midway down through the page. All right, so the coefficient matrix, some of these are constants. Okay, in other words, if you look over here, this is what you should be typing into the coefficient. Okay, the first top three are just they're just constants, but the others are formulas. Now, notice on my formula I use something called R1. Okay, now why am I using underline R1? Well, because Excel won't let you use R1 because it thinks that that could be column R, row 1, and it would get it messed up. So I did that. I made this the scope of just this sheet. Now the good thing is, and this is the mark of a good spreadsheet, we can set this up with formulas, okay, that coincide to the actual physical problem. Now, you're saying, well, how do I get these? You will learn this in circuit analysis next year. All we're showing you here is once you do the circuit analysis, how do you then go from that to getting your solutions? All right, so by doing this, if somebody changed one of these values in here, and it's from 40 to 20 or something, okay, you get all new values, everything's good. You don't have to come in here and say, oh, well, where was R3? I have to retype it again right there. No, you just keep it the way it was. All right, so this was, that was 50. Well, I guess this one right here is the one I changed, 40. Okay, I get it back to the way it was. All right, so all we need, we have a coefficient matrix. We have a right-hand side, which also has formulas. So if you change this voltage, you get different values. And I do a determinant of the coefficient matrix. I see that it is non-singular. It doesn't come up with 0 there. And then I do the coefficient. That's just the inverse, matrix inverse. And then remember, to get your solution for an equation, you take the matrix mult of your coefficient inverse times your right-hand side, and cancel. I'm not going to try to change it. And you get your answers. The Wheatstone is very similar to that. Okay, it has some different formulas you're going to use for the coefficient, and doing the same types of things. I just had a little extra step to show you that you do get the identity matrix over here. All right, that's all the new stuff. Now, if you set up these solving equations in multi-loop and Wheatstone, to do some of the homework problems, you can just right-click, move and copy, okay, create a copy, and then all you're going to have to do is just change some of the constants and you're done. So if you do something in a general way by using formulas, then in the future you can reuse all that work and just change the things that are in the boxes. All right, so good luck with the homework problems. I'm not going to show you anything about those because I got to leave something up for you to figure out. I'll see you next time in Chapter 6 when we'll be doing something about, well, I don't know what are we going to be doing. Linear regression. That sounds good. But this is a nice day in August. I want to get out of here, so I'll see you next time.